Mr. Abbott, and I would like to spend a little time with you going over this worksheet worksheet that we have on revolution and the seasons. Um, you definitely need to know what causes the seasons, and if you were asked to identify three major factors, one you can see in this diagram, which is the revolution of the Earth around the Sun. It takes 1 year for the Earth to make a complete revolution around the Sun, and it takes 1 year for a full sequence of our seasons. Another thing you can see from this diagram is at each of the lettered positions, A, B, C, and D, all four of those positions have the North Pole tilted or inclined in the same direction, which is towards Polaris. They describe that as parallelism of the axis. That would be another reason for the seasons. The major factor that determines that the Earth has seasons, though, is that the Earth's axis, as you can see in all four of the positions, is tilted. And the degree that it's tilted by is 23.5 degrees. You're going to see that number, 23.5, crop up all over the place. Now, when we look at this diagram, okay, A and C are the two positions that are along the long axis of this diagram. On the regions, they almost always position summer and winter at those two positions. And what you have to sort of ask yourself is, at which position is the North Pole tilted towards the sun's rays, and at which position is the North Pole tilted or inclined away from the sun? Now, over here at position A, the North Pole is tilted towards the sun. That means the northern hemisphere is getting more direct sunlight, so position A is going to be 621, which is going to be our summer solstice. Now, position C has the North Pole tilted away from the sun's rays. So for us in the northern hemisphere, we'd consider that our winter solstice, and the date for that would be 12/21. So when you look at an orbit diagram like this, you look for summer and winter first, then you fill in spring and fall. Now, they were nice and they drew the arrows showing you the Earth revolves counterclockwise. So after winter, you get the vernal equinox, which is 3/21. Okay, you hit the summer solstice, and then you would get the autumnal equinox at position B. So position B is going to be 9/23. If I labeled that, that would be the autumnal equinox. All right, so the chart on the bottom, the dates for A, 6/21, the season in New York is definitely the summer solstice. Okay, the location where the sun shines directly, okay, honestly, you might hear that referred to as the vertical ray. That's where the sun is hitting directly at a 90-degree angle. On June 21st, the vertical ray is going to hit 23.5 degrees north, also known as the Tropic of Cancer. Now, for us in New York State, on the when the sun is shining directly on the Tropic of Cancer, okay, we get about 15 hours of daylight. That's also can be called the duration of insolation. So another term for the hours of daylight is the duration of insolation. Now, B would be 9/23. It actually can vary. It could be 9/21. This would be our fall or autumnal equinox. The equinox is the day that every single location gets 12 hours of daylight and 12 hours of darkness. So over here, if it's an equinox, no matter what latitude you're at, you're going to get 12 hours of daylight. Another easy thing about the equinox is the vertical ray is going to hit the equator or 0 degrees. Okay, the only locations that can ever receive the vertical ray of the sun are definitely between the Tropic of Capricorn and the Tropic of Cancer. Now, position C, we already labeled on top as the winter solstice. Okay, so we're going to label this as the winter solstice. Okay, now the vertical ray has shifted as far south as possible for the entire year. So the vertical ray is going to be at 23.5 degrees south, also known as the Tropic of Capricorn. Okay, in the summer we gain 3 hours in New York State, so in the winter we lose those 3 hours, and we have approximately 9 hours of daylight on our winter solstice. Okay, the final season that you have up here would be 321. Okay, this is the spring. Can also be called vernal, but it's the spring equinox. The vertical ray has shifted back to the equator, which is 0 degrees, and every single location on the planet would receive 12 hours of daylight and 12 hours of darkness on any equinox. Okay, the Earth is tilted by 23.5 degrees. If the tilt was larger, we'd honestly have more seasonal variation. If there was no tilt, there would be no seasonal variation. At which position is Earth closest to the sun? Now, the point when we're closest to the sun is called perihelion. We're actually closest in this diagram at position C. So the northern hemisphere is closest to the sun in our winter months. The actual date for perihelion is something like January 3rd. Okay, so what season is it? We already said that for us, our closest approach is in the winter. Now, why are the seasons opposite in the southern hemisphere? Well, when you look at the diagram, when the northern hemisphere is inclined towards the sun, that means the southern hemisphere is getting less direct sunlight. And it's the angle of the sun's rays that really determines how much energy you're getting. So for this one, you might say, when the northern hemisphere is tilted towards the sun's rays, the southern hemisphere is receiving less direct sunlight, or they might use the word insolation. All right, so there you have it. Make sure you know this diagram and you can be able to identify each of the seasonal dates from the diagram.